Today we're going to look at linear programming, and this is in the book on page 174, and we're going to use this after section 3.3. So our goal today is to solve linear programming problems. So we're going to use a lot of the things that we looked at in section 3.3 on graphing systems of inequalities to find out what some maximum values are, minimum values, things like that. So few definitions first. Constraints, linear programming, the linear inequalities that form a system. Those are our constraints. Those are going to be the lines that we are, or the inequalities that we are graphing. The objective function is in linear programming is the linear function that is either maximized or minimized. Okay, they're going to ask us to find a maximum amount of money or a minimum amount of money or something like that. So the objective function is going to tell us what we're using for that. And linear programming is simply the process of maximizing or minimizing a linear objective function subject to a system of linear inequalities called the constraints. The graph of the system of constraints is called the feasible region. So our shaded area, or our solutions to all the inequalities, is going to be called the feasible region. So when we talk about optimal solution of a linear programming problem, it says if the feasible region for a linear programming problem is bounded, then the objective function has both a maximum value and a minimum value of the region. The maximum and minimum values each occur at one of the vertices, okay, or one of the vertices. So, example 1, here it says use linear programming to maximize a profit. So the first thing we're going to need to do is write some equations, both our constraints and our objective function. So here it says a potter wants to make and sell serving bowls and plates. So we have two things, bowls and plates. A bowl uses 5 pounds of clay and a plate uses 4 pounds of clay. The potter has 40 pounds of clay and wants to make at least 4 bowls. So we're going to write some constraints here. First of all, we know that a bowl uses 5 pounds of clay, so 5B, and a plate uses 4 pounds of clay, and that he has 40 pounds. Well, the amount of clay that we use has to be less than or equal to 40 pounds. So there is our first constraint. Now the second part says, and wants to make at least 4 bowls. So bowls is our B. So our second one, we know that he has to make at least that. So it's B has to be greater than or equal to 4. And then our restriction on our plates, well, we don't have any except for we know that he can't make less than 0. So we're going to have P has to be greater than or equal to 0. So here are the constraints that we're going to need to graph. Next, when they say let X be the number of bowls made and Y be the number of plates made, so if we use those, let's switch our variables to X and Y. So our constraints are going to simply be 5X plus 4Y is less than or equal to 40. And B, which is our bowls, are going to be X is less or greater than or equal to 4. And then Y is greater than or equal to 0. The profit of a bowl is $35 and the profit of a plate is $30. The potter's total profit P is given by the equation below, called the objective function. So if we write that function, it's going to be P equals, and we said we make $35 on the bowl, and again we're using X for bowls, so 35X plus and $30 on the plate, so 30Y. So there is our objective function. So how many bowls and how many plates should the potter described make in order to maximize the profit? So what we're going to do is we are going to graph the system. So we're going to pull up a graph. And we're going to graph these constraints. So if we look at our constraints, we know that X has to be greater than or equal to 4. So we have a vertical line right here, and our shaded area is going to be this way. X has to be greater than or equal to 4. We know that y has to be greater than or equal to 0. Well, if we graph that one, it has to be everything above there. So far we're looking at everything between the green and the red. Next, the other constraint is we have 5x plus 4y is less than or equal to 40, so our x-intercept is 8, and our y-intercept is 10. So we're going to draw that line. And if we check an ordered pair, we'll check the point 0, 0, plug it in. Is 0 less than or equal to 40? Yes. So our constraints are everywhere here. So if we graph this, now our feasible region is everywhere in this area. Now the difference between doing this and what we did before in section 3.3 is we now have to find the vertices of those 3 points. So this one is 8, 0. This one is 4, 0. And the next one is, it looks like it's 4, 5. But we're not 100% sure, so we should check it. So let's plug them in. 4 times, if we plug it into our constraints here, 4 times 5 is 20, 5 times 4 is 20, and so that is the correct one. So it'd be 20 plus 20 is 40, so that is correct. So there are our 4 ordered pairs. So what we're going to do is now we're going to check each of those. We're going to plug them in to see which one gives us a max, which one gives us a minimum, and so on. So we're going to take it and plug each ordered pair into our objective function. So I'm going to take the ordered pair 4, 5. That's what I'm going to start with. So if we plug that in, we're going to have 35 times 4 plus 30 times 5. And so we're going to do the math on that, and we're going to figure out what that is. Then we're also going to put in the ordered pair 4, 0. So it'd be 35 times 0 plus 35 times 4 plus 30 times 0. And we're going to figure out what that is. And we're going to also do the other ordered pair 8, 0. So it's going to be 35 times 8 plus 30 times 0. So now we're going to plug all those in, find out what values they give us, and that should give us our maximum or minimum values. So let's go back and plug in each of these points. 35 times 4, we're going to get 140, plus 30 times 5 is 150. So this one is going to give us 290. All right, the second one, we're going to have 35 times 4, which is 140, plus 0. So that one's going to give us 140. And the third one, we have 35 times 8, which is 280, plus 0, which is going to give us 280. So if we look at this question, we want to evaluate the profit functions, which we did. Here are the numbers that we got. So if we look at back to the question, it says how many bowls and how many plates must the potter make in order to maximize his profit? Well, if we look at these, his maximum profit comes right here, $290, when he makes the ordered pair is 4 or 5, and remember 4 represents our bowls and 5 represents our plates. So the potter should make 4 bowls and 5 plates. So your assignment is going to be on page 176, numbers 1 through 10. So you can stop the video right now and do those if you would like. Otherwise, I am going to do example 2 on page 175 if you would like to follow along with that. All right, so in example 2, here are the inequalities, and we're going to graph those constraints. So the first one, x is greater than 0, which is vertical line through here to everything on there. Second one, y is greater than or equal to 0. So it's going to be everything above there. Now, a lot of times when we do these problems, you're going to have those two constraints. So a lot of times we're going to only be looking at problems in quadrant 1. And the reason for that is we can't make a negative amount of bowls or plates like we did in the other one. We're not going to have negative amount of objects. So a lot of times we're going to be dealing with only quadrant 1. Now, if we graph the green inequality, so the x-intercept is 16, and the y-intercept is going to end up being 8. Okay, now I don't want to go all the way over and put 16 on my graph, so I'm going to put this in slope-intercept form. So I'm going to have 2y is less than or equal to negative x plus 16, which means y is less than or equal to negative 1/2 x plus 8. So now I can go down 1 over 2. I don't have to go all the way out, and I can draw this line. Pick my test point. Is 0 less than or equal to 8? And yes, it is. So this constraint has everything down below there. So now we're talking about the triangle on quadrant 1. And so if we do the same thing here, again, I can use a cover-up method, but I'm going to have a y-intercept of 35, which I don't really want. So I'm going to switch it into slope-intercept form. Which it looks like I'm still going to have a y-intercept of 35. So what I'm going to do is this. I'm going to put in some ordered pairs. So that I'm going to make a table of values here to graph this, because I don't want to put all the way up into, actually, we're going to do this. The x-intercept is going to be 7. And since I put it in slope-intercept form, I know that the slope is negative 5, which means I'm going to go down 5 and over 1. And I can also go up 5 and over 1. And so in this case, right there, we see where they cross. And I now have to find my shaded area, put in 0, 0. Is 0 less than or equal to 35? Yes. So it's everything this way. So now I have to find my feasible region. So I'm going to have, it's going to be in quadrant 1, up to the green, over to the blue, back up to the green, over to the red. So it's everything in here. So now what we need to do is we need to write down what those ordered pairs are. So it's 7, 0. This one was 6, 5, 0, 0, and 8, 0. So those are my 4 points that we need to now plug into our objective function to see what we're going to get for answers. So 8, 0 is the first one we're going to check. If I put that in, 4 times 8 is 32. So this is going to be 32. If we put in 6, 5, we'll just keep going right around down here. So 4 times 6, 5 times 0, or 5 times 5. So we're going to have 24 plus 25, which is 49. Then we're also going to put in 70. That's 28. And actually, we wrote this top one wrong. That should be the ordered pair 8, 0, 8, not 8, 0. So this is 0, 8, right, which will switch this. We'll redo that top one at 0, 8, which gives us 4 times 0 plus 5 times 8. So that's 0 plus 40, which is 40. And then the last one we had was 0, 0, which is obviously going to give us nothing. And the question asks us to find the minimum value and the maximum value. So when we look at this, obviously the minimum value occurs at 0, 0. So this one is our minimum value. And this one is our maximum value. So our maximum value occurs at the ordered pair 6, 5, and our minimum value occurs at the ordered pair 0, 0, with our maximum being 49 and our minimum being 0.